So far, we have defined the potential energy for the gravitational force and the force from the spring. However, not all forces that we can define the associated potential energy. The most important example is the friction. If we consider an object move on a rough horizontal plane under an applied force, we define here the object, which is the book, and the plane, the horizontal planes, and the system. Okay. So this is a system. The book and the horizontal surface. If we push the book to the right, okay, we push the book like this, and if we push it in a quasi-static process, that is, we push it very slowly, the applied force do work on the system, right? But this work introduce no kinetic energy to the system because we push the book very slowly. In the quasi-static process or the quasi-equilibrium process, it means that it is very slow. So it means that we introduce no kinetic energy to the system. And again, if the object is at rest initially, and when we push the object at the end, the book is at rest at the final position, and there is no change in the kinetic energy. The point is that once we release the book, once we release the applied force from the book will stay at rest. It will not move back as in the case of the gravitational force, but the book will stay at rest at the final position. So it means that we cannot say that the applied force store the potential energy to the system, because the potential energy, if we have the potential energy here, it will transform back to the kinetic energy as in the case of the gravitational force or the force from the spring. So we may say that in this case, the total kinetic energy the total mechanical energy is not constant. Okay, it's not constant. Even though if we put the kinetic energy to the system initially to the system, at the end, when we release the applied force, the book will stop eventually and it will not move back. So it means that the kinetic energy lost in a process of moving this book on the left horizontal plane. And if you look at the energy diagram here, it will decrease kinetic energy. Anyway, we will later define what we call the internal energy. The internal energy. The internal energy is the energy that is not in the form of the mechanical energy. For example, if you push a book on a large surface, and after you push the book, if you touch the book, you may feel that it's warmer. Or if you love your hair, you can feel that it's warmer. This energy, you can feel it from the temperature of the book or of your hand, is not in the form of the mechanical energy, but it's in the form of the internal energy. So we will have that if we include the internal energy to the kinetic energy, the total energy, which is the kinetic energy plus the internal energy, will be a constant. Okay, but in terms of the mechanical energy, we lost the kinetic energy and we do not gain the potential energy. Okay, we will talk about this internal energy at the end of this course. So I will not go in more detail on the internal energy this time.